Hello friends, today I'll discuss two very important questions related to Gell-Mann-Nishijima formula. So the first question has been taken from CSIR-NET exam 2015 June. The question is, the charm quark is assigned a charm quantum number c is equal to 1. How should the Gell-Mann-Nishijima formula for the electric charge be modified for the four flavors of the quarks? So we are having four options, A, B, C and D. So now let's solve this problem. So it's very easy to solve this problem because we know that the Gell-Mann-Nishijima formula is given like this: Q is equal to I3 plus B plus S over 2, where Q is the total source, I3 is the third component of the isospin, B is the baryon number, and S is the strangeness quantum number. So we can see that the Gell-Mann-Nishijima formula contains B plus S. Okay, so if we see the option A, it has B minus S, so option A cannot be the correct answer because it must be B plus S. Similarly, in option B, we can see that it is B minus S, so option B cannot be the correct answer. So in option C, we are having B plus S, and also in option D, we can see it is the B plus S. So the correct answer will be from C and D. So let's find out the correct answer. So let's check the option C. The option C is given by this relation, Q is equal to I3 plus B plus S minus C over 2. Now let's proceed to check whether this relation is correct or not. So we are having the quantum numbers corresponding to the charm quark like this. The charmness is plus 1, the charge is plus 2/3, the third component of isospin of charm quark is 0, baryon number is 1/3, and the strangeness is equal to 0. So now what will we do? We'll substitute these quantum numbers in this given option, in this relation, and we'll find the value of the charmness from these relations, and we'll check it whether it is giving me the charmness positive 1 or not. So let's proceed. So this is the value of Q, this is the value of I3 of charm quark, baryon number is 1/3, strangeness is 0, minus C. So from this relation we can simplify like this, and if we further simplify, the value of C can be calculated as -1. You see, so this cannot be correct because the value of the charmness is positive 1. Okay, so this option C cannot be the correct answer because it is giving us a -1 for the charmness. Okay, so now let's proceed for the option D. The option D is given by this relation, Q is equal to I3 plus B plus S plus C over 2. Again, we will substitute all the quantum numbers except the charmness like this. This is the source, this is the third component of isospin, this is the baryon number, and this is the strangeness quantum number. So if we simplify these relations, we can easily calculate the value of the charmness from these relations, which is giving positive 1. Okay, so you see, this is the correct option because from these relations we are getting the charmness of the charm quark as a positive 1. So option B is the correct answer. So from this discussion we can generalize that in case of the charm quark, the Gell-Mann-Nishijima formula can be modified like this: Q is equal to I3 plus B plus S plus C over 2. Okay, so coming to the next question, This is also very interesting because we already have the questions in the CSIR-NET exam in 2015, but if the question is modified with a bottom quark instead of a sum quark, so what will be the modified Gell-Mann-Nishijima formula? So the answer will be like this: Q is equal to I3 plus B plus S plus B. You see, this is plus B over 2. So let's verify this answer. We know that the quantum number related to the bottom quark are like this. The bottomness is -1, this is minus, the charge is -1/3, the baryon number is 1/3, the third component of isospin is 0, and the strangeness is equal to 0. Now substitute all these quantum numbers in this relation 1, except the bottomness of the bottom quark, and let's calculate the bottomness from this relation like this. Put the value of the charge here, the third component of isospin here, the baryon number here, and the strangeness 0 is here. So if we simplify this relation, we can calculate the value of the B like this, -1. Okay, so we are getting the correct answer because the bottomness of the bottom quark is -1. Okay, so the answer given here is the correct answer. So we can see that in case of the bottom quark, the Gell-Mann-Nishijima formula can be modified like this: Q is equal to I3 plus B plus S plus B over 2. Thank you very much.